concerning the shading of this conference room that sits in the bottom of the courtyard. Now, my suggestion is, okay, so the group has begun implementing a shading correction factor, but the group presented a binary correcting factor during the class hour early this morning, which I think should be improved by taking to the continuous nature of the shading effect. So the shading correction factor should not be a binary value, it should be continuous from 0 to 1. Okay. My suggestion is make the shading correction factor the fraction of the sunlit surface area, This is how this is the specific. So here I add a formula here in this cell, which is the maximum of 0 and the function of solar altitude angle and solar azimuth angle. I'll explain later. So this function will be something that you develop, you figure out, which has a upper limit of 1 and the lower limit, the lower values of this function may be negative. So I chose to use the maximum, this maximum Excel function to make sure that the value does not go below 0. This fraction of sunlit surface area can be as low as 0, but should not be negative. And once you have that, you can make that the shading correction factor. So the shading correction factor will be the fraction of sunlit surface area. And then you apply that to all the hours. Once you have that, you correct the direct solar irradiation onto this surface, which is by multiplying the GD, the capital D, by the correction factor. So you multiply the G sub D, that is for the no shading scenario, by the shading correction factor. Okay. And of course, it's all showing a name error because the function has not been defined. So let me explain how you figure that. I'll give you some hints as to how to get that function. So the problem is this. You have a box which represents the big box represents the courtyard, and then inside the box you have a smaller box, that's the conference room that sits at the bottom of the courtyard. The sun shines from above the opening of the courtyard, the opening of the top opening of the big box, and depending on the sun's location, the position of the sun, the shadow of the edges of the top opening may come onto the surface of the outside surface of your conference room, which causes the shading effect. As long as the shadow of the edges are on the surface or in a position that blocks the sun, you have the shading effect. So to quantify that shading effect, it's better, it helps to look at the problem from the two-dimensional views. So you look at the front view, and if the sun is at this position, and you see the shadow of this right-hand side edge comes down to this part, and it's off. It's on at the bottom of the big box, and it does not come across the surface of the conference room. So there's complete shading from that point of view. That's in the morning. In the afternoon, you would evaluate where the shadow of that left-hand side edge is. So this way, if you know where that shadow is, you can determine the vertical. You can determine the boundary of that sunlit surface area in one dimension, in this dimension. But there's another dimension you need to consider, which is the dimension, which is the shadow that's due to the south edge of the courtyard. This you need to evaluate from the side view. So in both views, there are two parameters of importance. One is the height of the courtyard h, and in the side view, the other parameter that's of importance is the depth of the courtyard. In the other case, in the front view, the parameter that's of significance is the width of the courtyard. So if you figure out the geometrical connections, the relations between these parameters and where the shadow is, you can figure out the fraction of the sunlit surface area of the conference room that sits at the bottom of the courtyard. It is challenging, but if you have enough time, you can do it.